Have you ever noticed that you look different in pictures than you do in the mirror? When you see yourself in the mirror, it is a mirror image of yourself, which is a flipped version of what everyone else, including a camera, sees. Why is that image flipped? The reason is that the image you see in a mirror is a reflection, which is energy in the form of light bounced back from a surface. Many kinds of energy can reflect, including sound, heat, and earthquake waves. In this lesson, we will focus on light reflection. Light reflection is very important because it's the reason we can see anything at all. When you see a red apple, it's because red light is bouncing off the apple to enter your eye. The air scatters around blue light, causing it to bounce into your eyes, making the sky look blue. The sun's light bounces off the moon, illuminating it in the sky. All of these bounces are reflections. It's easy to measure light reflecting on a mirror. Mirrors reflect so well because they're smooth and shiny, and so almost all of the light that hits it can reflect back off. However, light bouncing off any smooth surface can be measured. And so, since we can measure light, we can actually predict what the light will do and where it will bounce to. With this information, scientists have developed the law of reflection. The law of reflection says that no matter which direction light hits a smooth surface from, the light reflects back off at an equal angle. It bounces off from the midline of the smooth surface, reflecting on the opposite side of the midline, as demonstrated in this image. See how the light coming in from the left side bounces off the surface and then creates the same angle on the right side? That's because of the law of reflection. You may have noticed when looking in a mirror that, depending on where you stand, you can see different objects reflecting off. That's because of the law of reflection. When you change your position in relation to the mirror, you see different light reflections bouncing at the particular angle needed to reach your eyes. Next time you're riding in the back seat of a car, look at the driver's rearview mirror. Often, you can see the driver's eyes. And if they look up, they can see you. You can't see yourself, and they can't see themselves, but you can see each other. That's because you are lined up so that the light bouncing off the driver is at that equal angle to the light bouncing off you. That's also why you can hold a mirror up in front of you and see around a corner. Even on a sphere, we can understand how the light will be reflected off the smooth surface by applying the law of reflection. The light will always bounce off at an equal angle to the midline, and so we could calculate how the light would bounce off of the curvature of the sphere to create a reflection of the surrounding environment. Light reflection is energy in the form of light bounced back from a surface, and light can be reflected and measured from any smooth surface. Since we can measure this light reflection, we can predict how it will behave, giving us the law of reflection. The law of reflection states that no matter which direction light hits a smooth surface from, the light reflects back off at an equal angle.